Everybody, welcome back to another fun and exciting pre-calculus class. Today we will be jumping into chapter number 10. If you look down in your book, that is on page 188. Page 188. Today we'll be talking about analytic geometry concepts. So what is analytical geometry? Well, basically it's the idea of putting things onto the Cartesian plane. Now, if you've taken Algebra 1, if you've taken Algebra 2, you probably have a pretty good concept of what's going on with analytic geometry, at least the first part that we'll be talking about in lesson number 1. But it's always good to do some review, because if you don't do some review, then you are going to possibly miss some of these basic concepts that you're going to need for the later lessons. Okay, so let's go ahead and look down here. We're going to be talking about again, analytic geometry. It's the study of geometric characteristics of lines, curves, shapes, all kinds of different things that we put onto a graph, and those all come from algebraic equations. So basically it's taking an equation and then creating a shape or a line out of that equation. It is considered to be one of the greatest advancements in mathematics, and if you kind of skip down here to the end, it talks about analytic geometry is held an eminent and necessary part of training in every mathematician since its discovery. In other words, you can't be a mathematician, you can't go into engineering, you can't do anything in math if you don't understand analytic geometry. It's brought all the new advancements in any type of mathematical, scientific type field. They're all built on this. Calculus is built on this, and other things. So very, very important. Let's look down at lesson 10.1, intercepts, symmetry, and domain. What we're going to do is we're going to spend just a little bit of time on each one of those three different concepts. So the first concept that we'll be talking about is the intercept. So go ahead and look down here at the screen. I wrote intercepts. It is the point where a graph crosses or touches either axis. So it's where it touches the x-axis or where it touches the y-axis. Again, I don't want to insult your intelligence here. Most of you know what an intercept is, so I'm not going to spend a ton of time on it. How do we find them? And again, probably you're like, I know how to find them because I did it in Algebra 1 and I did it in Algebra 2. Okay, but maybe some of your classmates that are watching, they don't remember how to do it quite as well. So let's go ahead and take just a minute and let's talk about it. Finding the x-intercept. Number one, we want to replace the y value with 0. So whatever y equals, we're going to put in 0. So when you see y in the equation, you're going to put a 0 right there. Okay. Now we're going to solve it for x, and then we write the coordinates. And you say, well, what is the coordinate? Well, the y-coordinate would be 0, so whatever it is, your x-intercept is always going to be something like, whatever your x equals. Let's say x equals 3, for example, and then your y is always going to be 0. So that would be how you would write an x-intercept. In other words, because y is 0, it doesn't go off the line, and if we're going over to 3, that's where the line would touch or cross the x-axis is at 3. Okay. The next one is finding the y-intercept, and the way that we do that is exactly the same way, except for now we're replacing the x with a 0 and we're solving for y. Let's practice. Let's do one. We'll first solve it for x, and then for the x-axis, and then we'll solve it for the y. So the first thing that we want to do is we want to put a 0 in here instead of y. So we'll go 9x squared plus 16 times 0 equals 144. Obviously, this just cancels out because anything times 0 is 0. And so we get 9x squared equals 144. A couple different ways that you could go about this. You could divide both sides by 9. And I guess that would be a way that you could do it, but I think factoring this is going to actually end up being just a little bit easier. And so if we move the 144 to the other side, we get 9x squared minus 144 equals 0. This is what's called a difference of two squares. And so we're going to end up with a conjugate from this. So we're going to end up with 3x plus 12, 3x minus 12. And those would both equal 0, right? So we could solve this one first, and we'll take the 12 to the other side. So we get 3x equals negative 12. Divide both sides by 3, and we get x is equal to negative 4. Okay, so there we go with the one side. Over here, we'll do this one, and same thing, moving it over there. 3x equals positive 12. And so we're going to get x equals positive 4. So remember, whenever you have a quadratic, whatever your exponent is here, right, if it's a squared, you're always going to get two answers. So in this case, we get plus minus 4. All right, so what we would do here is we would write our answer. Remember, we had to write our coordinates. So we're actually going to get two coordinates that it crosses. In this case, we're going to get x equals 4. We could do plus minus 4 comma 0, and that would work. Or you could write it, you know, plus 4 or just 4 comma 0 and minus 4 comma 0. You could do it either way. I'd probably prefer that you write it that way, but you could write it out as well. Either way, I like to save time when possible, so that would work. But either way that you choose to write that is fine. All right, so now we're going to do the exact same thing, except this time the only change is that we are going to put in the 0 for x. So in other words, we're going to solve for y this time. So now we have 9 times 0 squared. That's going to cancel out, and we're going to get 16y squared equals 144. We can do the exact same thing that we did last time. Let's just try to solve it a different way. So let's try to, this time, before we do that, let's try to divide both sides by 16 and see what happens. So we get y squared equals 144 divided by 16 equals 9. So that would equal 9. And now we would just square root both sides. And maybe you say, Mr. Steve, that's easier than doing it the way you did it the other time. I agree. You can do it either way. I wanted to show you both ways on how to solve these. So that's going to cancel that squared, and we're going to get y equals the positive negative value of 3. So that's the x-intercept. How would we write that? We would write this one, 0 plus minus 3. Or you could write it out, 0 plus 3 and then 0 minus 3. That would be fine as well. Okay? So that's intercepts. Intercepts, hopefully, again, that's something that you've been doing for a long time, so you remember how to do that. Next point here is symmetry. Symmetry is when we have the shape that is exactly the same on both sides of a point or a line. In this case, we have a point of symmetry right here with this hourglass. This point of symmetry is kind of like it's reflecting the shape on both sides. So in other words, you have this triangle on the top. It's reflected on that point of symmetry down here to the bottom, and we get the exact same shape. This hourglass has symmetry, and it has symmetry from what's called a point of symmetry. Now, on this shape, we have a square kind of turned on an angle here. And what you end up with, and you're like, no, that's a diamond. I know, it's a square turned on its side, which is a diamond. So anyways, we have a diamond or a square, and then we cut it right here with a line. This is what's called a line of symmetry. So go back here, and that is a line of symmetry. This line of symmetry gives us an equal piece up here as what we get in the bottom. Again, it's reflecting over top of that line this time. The first one reflected over top of a point. This one's reflecting over top of a line, giving us the same thing on both sides of the line. So that's symmetry. Now, how do we find symmetry in our graphing? How do we find symmetry in our equations? Well, the way that we do it algebraically is we are going to, and there's different types of symmetry. The first symmetry is to the x-axis. So how do we find out if something is symmetrical? It might look symmetrical, right? But how do we verify it? How do we know for sure that it's symmetrical? We replace the y value with negative y. If the resulting equation is an equivalent equation, then it is symmetrical. Okay. The next one is with the y-axis. How do we do that? Same thing, except now we replace the x with the negative x. If the resulting equation is equivalent, then it is symmetrical. The last way that something can be symmetrical is on the point of origin. So in other words, what's on one side of the point of origin, actually it doesn't have to be the point of origin. It could be any point, but for right now, we're only going to learn the point of origin, okay? So finding the symmetry to the point of origin. What would you do here? You would replace the x with negative x and replace the y with negative y. You have to do both of them in order to prove symmetry based on the point of origin. So here's what we're going to do. We're going to do this 3 times, okay? So we'll do it the first time, we'll do it for the x. How do we do it for the x? Well, we replace the y with negative y. So negative y squared equals 4x. Okay. And if you want to know where I am in your book, I'm on page 190 in your book, page 190. Okay. Now, one thing that is important is we make sure that we are putting this y in a parenthesis. In other words, the squared goes to the negative y, not just to the y. It's not like the negative is sitting outside of it. We have to square the negative as well. What happens when you square the negative is you end up with what? You end up with a positive. So in other words, y squared, negative y squared equals, because it's y times y, right? Negative y times negative y, it's the same thing. We end up again with y squared equals 4x. So in other words, it came out the same. So is that symmetrical? Yes, it is. Okay. So that is symmetrical to this would be to the x. Okay, the x-axis. The next one in the middle here, we'll do the y. So what we want to do is we want to focus this one this time. So we're going to say y squared equals 4 times negative x. Okay, what is 4 times negative x? Y squared equals negative 4x. Is that the same as that? No, it's not. So that one is not going to be symmetrical. So this one is a x. Wrong. Okay, not x is in the x-axis, but x is in wrong. Okay, so that one is not symmetrical to the y-axis. All right, this last one, we want to see if it's symmetrical to the point of origin. And maybe you can like kind of use your brain there and kind of think, well, maybe since one of them's not, then it's not going to be. Well, let's just do it and find out. So we have y, negative y, and that's going to be squared, equals 4 times negative x. We changed both of them this time. So what happens here is I end up with my y squared again, because negative y times negative y equals y squared, equals negative 4x. And again, this is our original equation. This one does not work either. Okay, so in this case, this one is symmetrical to the x. So let's go back up here. It is symmetrical to the x. It is not symmetrical to the y. In other words, when we did the y, that was the one we did in the middle, we got 2 different equations right here. So it is not symmetrical to the y. And then the point of origin, when we did this, we ended up with 2 different equations as well. So it is not symmetrical to the point of origin. So whenever you get one of these questions, it's basically just going to ask you, is it symmetrical to the point of origin? How do you do it? You just follow these 2 simple steps. Replace the x with negative x, place the y with negative y. Solve it out. Does it equal itself? Does it equal the original equation? Then yes, it is symmetrical to origin. If the answer is no, then it's not symmetrical to origin. You do that same thing with the y-axis and with the x-axis. All right, the domain and range. Hopefully you remember what the domain and the range are. The domain is all possible real values for the dependent variable, for the input value, for the x value. Okay, so this is the x of the equation. The range is all possibilities or real values for the independent variable, which is the output variable, or that is the y variable. Okay, so let's look at some things that can limit the range or the domain. The first one is, and you probably already kind of noticed that on one of the last questions, was if we raise it to an even power, right? Because if you raise something to an even power, it cannot be negative. Because when you multiply a negative times a negative, you always get a positive. The next thing, number 2, is a variable under a radical, okay, with an even index. So if you have a negative underneath of a radical sign, like let's say negative 9, okay, that does not have a real answer. It has an imaginary answer, but it doesn't have a real answer. So nothing negative under the radical sign of an even index. In a cube, you could actually get an answer for that, but a real answer, but not in a square or any other even index. Number 3, the variable in the denominator cannot be 0. And that's like this. So if I had 3 over 0, that comes out to math error. You can never have 0 in the denominator. So we can't zero out our denominator. And then number 4, some trig functions, we'll talk about this later, but some trig functions can limit your domain and your range. All right, how do we determine the range of a function? Okay, this is not that difficult, but maybe some of you have struggled with domain and range in the past. Well, let me put it as simply as I can. Number 1, solve the equation for y in terms of x. You'll see what I mean by that in a second. Number 2, determine if there are any limiting factors. In other words, one of these limiting factors right here, 1 through 4. Okay, is there a weird trig function going on? Do we have a negative under a square root sign? Something like that. If not, so if there's no limiting factors, then your range is negative infinity to positive infinity. And that's how you would write that. Negative infinity to positive infinity. Now, if there is a limiting factor, if there's something that says, oh, I can't have 0 in the denominator, for example, then you would write it basically the same way as this, except for you must write the exclusion to those numbers. Whatever's excluded from the values, you have to write that those are excluded. All right, so let's try this one. We want to solve this for y. So I'm going to go ahead and I want to get y by itself. If you don't know how to do that, then you need to go back and figure out how to do that. You should know how to do that by now. So this is going to, I'm not going to go ahead and do it the whole thing, but basically this is going to give me y equals plus minus 3/4 square root of 16 minus x squared. Okay, and so that's getting y by itself. Now what we want to do, the only thing that matters right now, the only thing that matters, because this doesn't matter. And you say, well, why not? Because there's no x in the denominator, right? There's no limiting factor on this. So we're not worried about that right now. The only thing that we're worried about is we cannot have a negative under there. So what you would do is you would take this determinant right here and you would set it equal to 0. 16 minus x squared equals 0. Go ahead and move the 16 to the other side. Negative x squared equals negative 16. Multiply each one by a negative 1. We're going to get x squared equals 16. Square root both sides. We're going to get x equals plus minus 4. All right, so what does this mean? This means that our domain has to be between -4 and +4. So our x has to be between this. And you could write it a couple different ways. You could write it like this, or you could write it from -4, comma, +4. And those would be included. So -4 and +4 are both included. So you'd put it in brackets, depending on what notation you want to use there. In other words, every value in between -4 and +4 work in there. Any value outside of that domain will not work. It will make this go negative. Okay? All right, look over on page 192. Page 192. We'll do this next one. So now we're doing the same thing, okay? We're finding the domain of this. How do we do that? We solve for y in terms of x. So let's get y by itself. This one's pretty simple, right? Is just moving x to the other side. So we get y cubed equals x. Now we need to solve for that. And you're like, well, it's already solved. No, it's not quite solved. So we need to do the cube root of both sides there. That's going to cancel, so we're going to get y equals the cube root of x. Now it's solved out. Now there's nothing else that we can do. So now you ask yourself, is there any limit there? Now, remember, you might be thinking, well, x can't be negative. Well, hold on a second. Remember, it's in a cube root. In a cube root, it can be negative. For example, the cube root of -8 is -2, because -2 times -2 times -2 equals -8, right? -2 times -2 is +4. +4 times -2 is -8. So this cube root actually can yield a negative answer. So there are no limits on this one. This one, it could be anything underneath there. It could be positive, negative. There's no limiting factors there. So on this one, it would be -infinity to +infinity. There's no limiting terms right there. Remember, you can't include infinity, so you can't put them like this. Why not? Because you can never reach infinity, so you can never include infinity. So the concept there would be you can't include it, so you put a parenthesis around it. You could also do it by, -infinity. That's a terrible infinity. -infinity, let's try it again. Is less than x is less than +infinity. You could do it like that as well. Two different ways to kind of notate that. But all right, well, that's about all I have for you in this lesson. I know there's quite a bit packed in there, kind of a longer lesson, but most of it was review. Hopefully you remember how to do that from Algebra 1 and Algebra 2. If you missed anything, go ahead and slide it back, watch it again, practice some of these, okay? Go to the practice problems and try some of these. And if you can't remember what to do, scroll back that video, watch it again, and find out what to do, okay? All right, we'll see you later. Have a good one. Bye-bye.